Welcome to Pachera Talks. Today we are going to talk about Azure DDoS Protection in our Security Specialist series. So, before we dig into the service that Azure offers, which is Azure DDoS Protection, let's talk about few words. What is DDoS? So, DDoS is a kind of attack which attempts to exhaust the resources where the applications are running. So what it does, it sends so many requests so that the resources where the application is running gets exhausted, and the application will become unavailable for the legitimate users. So that's kind of attack is DDoS attacks. There are multiple ways they attack it, but the idea is do not let the legitimate users reach to the application. Either you send so many bogus traffic which will eventually exhaust the resources. For example, let's suppose these are the application running at the back end of maybe a load balancer or application gateway, as you see here. And here is somebody or who is actually attacking, or you could say attacker. It will somehow compromise the other computers right here. Okay. And these computers are called bots. And with the help of these computers, there could be many number of computers sends traffic to this uh, endpoint, publicly available endpoint. And what would happen if a legitimate user is sitting here and try to send a traffic through his phone or laptop or tablet, it will it will get lost in between the traffic of so many computers sending to this particular endpoint. Or maybe when it will reach here, these application has already exhausted their resources and are down if they are not designed properly. Okay, so in a nutshell, this is what the DDoS attack is. DDoS is distributed denial of service attacks, which aims to disrupt the normal traffic of a targeted server, service, or network by overwhelming, as you can see, so many requests, by overwhelming the target or its surrounding infrastructure with a flood of internet traffic. So, if this is not here, this attack is not happening here, let's suppose, if I take it out, then this guy can simply send request here without any trouble and will get the response in back. But that's how that's the usual and normal way of running an application, and this is the attack happening right now, and resource getting exhausted, and the legitimate users request getting lost or not catered by the application. So this is the high level idea of what is DDoS attack. Now we have already defined it. Now DDoS attack can come from multiple compromised computers, as I was mentioning. So this is the actual attacker who compromise so many computers and use them to send the traffic to that particular endpoint. And we call these computers as bots, you could say. But the point is, how can we protect ourselves from such DDoS attacks? Well, I think you have your answer already with you. That's what we're going to study today, Azure DDoS Protection. Yes. Azure DDoS Protection combined with application design best practices. Because if you just enable the Azure DDoS Protection, it will not guarantee that it will protect your application and legitimate users will able to reach there, but you have to design your application as per the best practices on cloud to protect your application from DDoS. Let's take an example to understand. Nobody can simply say with looking at the request if whether it's a DDoS request or not. it's a pattern. When the attack happens, it realizes, it checks, and then start blocking. Until then, you should have your application running maybe with scalability, horizontally scalable, so that it can digest that many request until the attack recognized, right? So just an example. So Azure DDoS protection by itself is not the foolproof plan, but along with the application design best practices, it is. And why is that so? If we need to go a little deeper, because DDoS protection, Azure DDoS protection protects layer 3 and layer 4 only. It doesn't protect on layer 7. So another best practice of the application is app gateway, which I mentioned here, because app gateway provides WAF, right? So Azure DDoS protection plus application design best practices will help us protecting our application from DDoS attacks. Do not get surprised with this. This is true. I can show you in the documentation as well. Oh, we will show you that. So you need to plan your application as per the best practices of designing it on cloud, and you need to protect your layer 7 through WAF. Now WAF will take care of the DDoS attacks on layer 7, but the DDoS attack on layer 3 and layer 4 will be taken care by the Azure DDoS protection. So before we dig into the different types of DDoS protection, as you can see, network and IP. Let's go through some examples just to understand how exactly it works. What are the different features that we will get when we opt for Azure DDoS protection? So the very first is, as you can see, always on monitoring, which simply means Azure continuously monitors your application traffic to detect unusual patterns that may indicate a DDoS attacks. See, it monitors and detect the unusual pattern. So until that pattern gets detected, your application should have that much of resource to cater those requests, maybe scale horizontally, so that DDoS can identify the pattern and block it, right? So you have to design your application accordingly. We can take an example here to understand. Let's suppose a company runs an e-commerce platform that experiences high traffic volumes during holiday sales. That's expected, right? But the risk of DDoS attacks is particularly high during these periods because of the complexity of finding out which is legitimate or which is not, or whether it's a DDoS attack or it's the sales crowd. So what they do, they utilize Azure DDoS protection, always on traffic monitoring, which ensures that during these critical sales periods, traffic to the e-commerce platform is continuously scrutinized for unusual patterns that might indicate a DDoS attacks. The system automatically starts mitigating an attack as soon as it is detected. So it will help in maintaining service availability even under attack. It's keep on monitoring, detecting, and mitigating. But it will take some time to identify whether it's an attack. And then we have adaptive real-time tuning. What it is? Well, this feature learns what normal traffic to your application looks like. And how it actually learns? By observing it for a long time, over a period of time. As your traffic patterns changes, the service adjusts its protective measures to ensure they are always effective and tailored to your current needs. So it is backed by AI and ML. We can understand this with this simple example. Let's suppose there is a financial service firm offers online banking services that see fluctuating traffic patterns depending on the time of the day and month. Okay, higher during the paydays, we can easily relate. So adaptive real-time tuning helps the firm by continuously learning the normal traffic patterns of its banking portal and adjusting DDoS mitigation policy accordingly. right? Let's suppose for 29 days the DDoS is observing, and on the 30th day when the salary comes or payday comes, it seems unusual traffic and starts blocking it. No, it won't do it. It will learn properly and accordingly uh, apply that adjustment on the policies. So this ensures that the protection measure are always calibrated to the current level of expected traffic, reducing false positive, which is most important. Again, if you're not allowing legitimate users because you are blocking false positive, it doesn't make any sense, right? So that's why adaptive real-time tuning. Then we do have an option of analytics, metrics, and alerting, which means Azure applies specific security rules for TCP, SYN, TCP, UDP traffic. So what it means? It applies security rules automatically on these kind of issues based on the learned traffic patterns. So if traffic exceeds normal condition, indicating a potential attack, Azure starts mitigation efforts. Metrics and alerts provide real-time data during and after an attack, which is very much needed. So you can understand this with the simple example. Maybe it's irrelevant from the technical perspective, but it will help us to understand this feature. It is like similar to your car's dashboard that alerts you when you exceed speed limits or when there is an engine problem, helping you to react swiftly to potential issues, just like any other notification. Right now, let's put it in the perspective of Azure DDoS Protection, where we have an online gaming company which hosts multiplayer games, where any latency or downtime directly impacts user experience and satisfaction. So, a company uses this feature, detailed analytics and real-time metrics provided by Azure DDoS Protection to monitor traffic. They set up alerts for DDoS attack signs such as spikes in traffic that do not correlate with typical gameplay patterns. These alerts help them respond immediately to potential threats, potentially averting service disruption, proactively prepared for the things. All right, so attack analytics is another feature we get. So, what it is? Well, during an attack, Azure provides detailed reports every 5 minutes. Yes, you heard me, every 5 minutes, and a summary after the attack ends. This data can be streamed to tools like Microsoft Sentinel for further analysis. So, we can understand this with a simple example. Like imagine receiving a detailed report from a security system after an attempted break-in, showing how the intruder tried to enter and at what times and how security system responded. So throughout the attack, the service utilizes Azure DDoS Protection to get detailed reports every 5 minutes, as I have already mentioned, helping them understand the attack vectors and scale of the problem. Post attack, a comprehensive summary helps them review and strengthen their defenses based on the specifics of the attack for the future. Now, we also get uh, metrics and alerting. We have mentioned summarized data from each attack is available in Azure Monitor. You can set up alerts for the duration of the attack to be notified immediately of potential threat. This is something which are more interested in because these are almost kind of similar. So DRR, it's DRR, Azure DDoS Rapid Response. What it is, in the event of an attack, you can access the DDoS Rapid Response team for real-time assistance during and post-attack. Yes, MS got a team. They're working on these kind of attacks continuously and available for you for your service. So we can understand this with this example. let's say during a major promotional event, a retail company's infrastructure comes under a sophisticated DDoS attack. The company engages DRR, accessing expert guidance to help mitigate the attack in real time. The DRR team assists in tweaking the mitigation strategies to effectively counter the specific nuances of the attack. They are experienced, they are skilled, they have a lot more information and can guide us. Then finally, we need to combine this DDoS, as we have already mentioned here. This alone would is not suffice. We need this as well, application design. So when combined with WAF, Azure DDoS Protection Shield, both L3 and L4, because this is what they do. So multi-layered protection help us prevent this DDoS completely, along with the help of this service of Azure. So we can take this. Let's try to understand this with some real life example. Like imagine wearing both a bulletproof vest, which is like a network layer protection, and a raincoat, application layer protection in a storm, ensuring comprehensive protection from multiple uh, types of threats. I know it's a silly example, but I hope it makes sense. If it doesn't, let me take another example, just hit my mind. Let's suppose there is an enterprise which has their application running, needs a robust protection for its application, which is accessed by clients worldwide. Let's say it's global. The provider uses Azure DDoS protection in conjunction with Azure Application Gateway WAF. Okay. This setup ensures comprehensive defense, protecting against both volumetric network attacks on L3 and L4 and sophisticated application layer attacks like SQL injection and cross-site scripting on WAF layer 7. Okay. So these are some interesting features that we get through Azure DDoS protection. And of course, extensive mitigation scale and cost guarantee, because Azure DDoS protection can handle even the largest known DDoS attacks with its global capacity. It also offers a cost guarantee compensating you for resources used during a documented attack. But these kind of offering we do not have with both these queues that we get, or both the tiers that we have in Azure DDoS protection. So let's see, or let's find the comparison on the Microsoft documentation for these two tiers. All right, so Azure DDoS protection comes in two-tier: network protection and IP protection, and basic DDoS is always there. Okay, so let's quickly check the network protection and IP protection right here. So this is Azure DDoS protection. This is what the Azure DDoS is, and these are the tiers. All right, you can see all these features that we were talking about: active traffic monitoring, automatic attack mitigation, alerts, all these things. If you see DDoS IP protection, DDoS network protection, they are like two tiers. Network protection has more features. Till here, they have all the same features that we talked about, like public IP standard tier protection for both. But the basic is with, because we used to have basic as well. We still have basic, but earlier there was no standard, only the basic IP. So if you're still using basic IPs, then you need to protect it because DDoS affects the publicly exposed endpoints. Then you need to have network protection. If you need DRR that we talked about, rapid response support, you need network protection. If you want cost protection, the resources which were used during the time of attack, and you want to protect your cost during that period, then you need to have network protection. Even there is a discount on the WAF. If you're utilizing WAF as per the best application practices, you need network protection. So these four things you get extra in network protection. But if you have a like single public standard IP, you could use only DDoS IP protection. instead of going through this, because this is very expensive as compared to DDoS protection. Because DDoS protection, IP protection is charged as per the IP protected, but network protection charged as per 100 protected IP address. Okay, so it will protect the entire network up to 100 public IP addresses, but this one only the single public IP address. Now, if I could show you price comparison between these two, come on, come here. Okay, as you can see, network protection is $29.5 per resource, and IP protection is $199 per resource. Do not find yourself saying like it seems very cheap as compared to IP. This is when you have extra, like here you can see. Network protection cost begins once DDoS protection plan is created. IP protection costs begin once the public IP address is configured with the IP protection. Okay, when IP protection is enabled for the public IP resource and the DDoS protection plan is created and enabled on its virtual network, customer billed for the lower per public IP resource rate. In this case, we'll automatically start billing the for network protection. So let me clarify this for you with this example. In this example, we compare the cost of network protection and IP protection for a virtual network with 10 public IP address. And let's assume you only have one subscription, your tenant, you create a network protection plan, and the plan includes protection of 100 IP address, as I've already mentioned. If you go with network protection, you get the protection of 100 public IP address. But in IP protection, you can choose. For example, for 10, you can have you can protect those 10 only. But here you get the option to protect 100 public IP address. So that subscription is billed for 2944 USD per month. Okay, because 29.5 into 100 resources. That's why, because you get here it says per resource, but you have to take the 100 resource from the beginning, not 10. If you have only 10 IP, you still have to pay this much. But here, if you have 10 IPs, you only need to pay 1990. Okay, that's why it was showing 29.5 per resources. I hope it is clear now. Very well. Now, since we are done with the DDoS protection, what it is, there are different tiers, network IP, it saves L3, L4, for L7 we need WAF, and these are the features that it provides. We have almost covered everything regarding this, but I would like to talk about a little bit on design best practices for the cloud application, because only then it is effective, otherwise you are still vulnerable. So the very first thing is these are some points for the best practices. You should design for security. Incorporate security throughout the application lifecycle from design through operations. Know your application's architecture, typically traffic volumes, connectivity models, and exposed service endpoints. Ensure applications can handle unexpected or malicious loads without service disruptions, hence the scalability. Design application to scale out horizontally to meet increased loads, especially during DDoS attacks, because it will take some time to detect the patterns and mitigate it or block it. Use multiple instances of services to enhance resiliency and scalability. And of course, you could apply defense in depth. What it means, like all the layers are secure. Implement multiple layers of security to reduce the likelihood of successful attack. Use approval list and NSG to restrict unnecessary exposed IP addresses and ports. You can get the recommendation from the MS Defender, and all those layers, your data layer, your application layer, your network layer, all those layers, you should have the protection applied, including your identities, of course. Then use the virtual network, because private connectivity is always best. If you have not exposing your VMs or anything inside a virtual network, it is already protected because it's a private network. So deploy Azure services within a virtual network to allow resources to communicate through private IP addresses. Even for the Azure PaaS services, go with the private endpoint. This will help. Or go with the service endpoint along with the policies. Private endpoints always preferred though. Then, if you have your on-premises, you got to protect them as well. Reduce the exposure of on-premises resources to the public internet by leveraging Azure capabilities. Deploy public-facing components of your architecture in Azure to utilize its advanced DDoS protection and reduce the load on on-premises resources. These are some architectural tips to design your application so that you can utilize or save your application from the DDoS protection, from the DDoS attack, along with the Azure DDoS protection plus application design best practices. I hope it was informative and you guys enjoyed the video and learned something new today. Well, thank you for watching and you guys have a wonderful day. Bye bye.